Here goes the next video of the Ethical Hacking book series, and this one is stealing and cracking passwords. Kind of excited about this one. Let's go ahead and get started. For the want of a nail, the shoe was lost. For the want of a shoe, the horse was lost. For the want of a horse, the rider was lost. For the want of a rider, the battle was lost. For the want of a battle, the kingdom was lost. And all for the want of a horseshoe nail. Benjamin Franklin. Alright. Alright. Hackers often compromise websites and APIs by finding ways to inject their own code. This chapter will introduce you to one of these techniques called SQL injection. And you will use it to extract a database of usernames and passwords from a web server. As a security measure, servers often store hashes of the passwords instead of plain text passwords. We'll explore multiple ways of cracking these hashes to recover the original text, and then use tools to automate the process of logging into a service which with each stolen username password pair. In the process, you'll learn a little bit about how hash functions work and how browsers craft HTTP requests. SQL injection. SQL injection vulnerabilities occur when developers incorrectly process user input and use it to generate structured query language SQL queries. SQL is a programming language used to add, retrieve, or change information in a database. For example, in a database that stores user personal information, the following query might return their first and last name of the user, whose social security number is 55555. Fake number. Select first name, last name from users, where SSN equals 55555. A complete introduction to SQL syntax is beyond the scope of this book, but SQL databases are essentially organized into tables, each which consists of columns and rows. Each column has a name, such as first name, and type, such as text. The query shown here, called a select query, is designed to retrieve data from a table. Select queries have three parts called clauses: select, from, and where. The select clause specifies the list of columns you'd like to retrieve. In this example, we're retrieving the first name and last name. First name and last name columns. From clause specifies the name of the table from which we'll retrieve the data. Lastly, the where clause specifies the attributes of rows we want to retrieve. For example, where SSN will 5555 will retrieve rows that have the value 5555 in their SSN column. Of course, programmers rarely write these queries manually. Instead, they write programs that can generate these queries whenever added. Thus, to allow for more generic queries, a programmer might replace the hard-coded social security number with a variable such as ID. Select first name, last name from users where SSS equals ID. Replacing the fixed value with a variable allows a program to easily fill in missing information to generate queries. The query will now return the first and last names of the record associated with any ID value the user supplies. You may find queries like these embedded with all sorts of apps. For example, a customer service agent might retrieve someone's information by entering their social security number into the text box in a banking app. However, because a program inserts the social security number directly into the SQL query, attackers can use the text box to insert any value they'd like to query, including their own SQL commands, instead of the string the command expects. For example, imagine a attacker enters the following: union select username password from users where 1 equals 1. The web app will replace the ID value with the hacker's entry. And because the entry contains SQL code, the database will execute the following query. Select first name, last name from users where users SSN equals union select username password from users where equals 1 equals 1. This query selects the first name and last name fields from the user table if the user's SSN field is empty. The union command then joins this value with the second query's result, which the attacker supplied as user input. This query returns the user's name and password for all entries given that they all match the required 1 equals 1 is always true. Notice how carefully crafted the injected SQL command is. In particular, it starts and ends with a single quote. This is necessary because SQL database will execute only valid queries, so we must ensure that it remains valid even after the injection. By including the one half a quote before the union keyword, we close the previously clear query. Later, we include another quotation at the end of the injected command to ensure that the trailing quotation mark left over from the original query is closed. SQL injection belongs to a broader class of attacks called injection attacks, in which attackers rely on user input to sneak their code into the application. Many web apps sanitize input to remove characters associated with injection attacks. For instance, they might replace quote characters with a backspace quote, a process called escaping. This means that you often must craft your injections cleverly. The Open Web Application Security Project, OWASP, has a cheat sheet on ways to prevent injections attacks. Alright, let's download that. Let's get that cheat sheet. This is good to have. So, bam! Injection prevention cheat sheet. This is awesome. Stealing passwords from a website database. To practice performing SQL injections, activate the multi-day web app on your Metasploit virtual machine. Adrian Crenshaw and Jeremy Drew designed multi-day to showcase common web vulnerabilities, and it comes pre-installed on your Metasploitable server. However, you must configure it first. Log into Metasploitable with the username and password, and then edit the config inc file, which you can access with the following command. Alright, let's get everything started. Alright, we're back. Got everything running. Let's enter in this code. So sudo vim var www mul mutil lid what the hell config .inc. Alright, that's what I got. Let me see. Yeah, looks like what I have. Oh, it says OWASP. All right, change the DB name variable from Metasploitable to OWASP 10. So instead of Metasploitable database. All right, how the hell are we gonna do that? All right, let's figure this out. Oh, crap. What the heck? Where I put that stupid thing back? Oh, there you go. Oh, wasp 10. Samurai. Insert. Oh, insert this. I can't remember how to insert this. Let me Google this real quick. Ah, man. Okay, let's try this again. Mm. Oh, I forgot to do something. I forgot this open comma over here. Yeah, what did I do? You know what? I'm just gonna write that, copy and paste it somewhere because I can't see. Right? So I'm just gonna write that in, like in my notepad. Copy and paste because I might be doing something wrong. That looks right. If not, we'll try something else. All right, we back. Oh my gosh. So, figured it out. In the book, it actually has the right um, SQL injection command, but it's right here. So, this is the one that. So, this select username, password from users where. No, actually, that's not the one. It's this one. No, 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 no. What did I do? Oh, so it's not these. It's just this where one equals one. Okay. This query returns the username and passwords for all entries given that are matched. They require one equals one is always true. So this where one equals one is what I tagged on to this um, this command that they had us do. So this was all correct. Accounts where, but you put where one equals one on the end of this, and then it pulled up. Um, it pulled up. Man, yeah. So it pulled up all the passwords. So I put it in password, and it pulled out all this stuff. So admin pass, signature monkey. I mean, they gave me all the usernames and passwords. Check this one out. Username Ed, password Pentest, signature command line Kung Fu. Anyone? Awesome. Wildcats. I love Sands. I like the smell of con funk. Stupid. Anyways, so that worked, and let me show you what I did. So since you couldn't see it in here, right? Um, what I did was, man, what's going on here? Um, I have a notebook. I mean, a notepad, right? I opened up Notepad, and I messed with it here. So if you read it, it has different columns, right? Accounts, passwords, users. So this is the one that I used. You can select from accounts where, and then I just changed, instead of in the book, I put the one equals one, just like that, and I just copied and pasted that one into there, and then this came out. I'm gonna keep these, okay, exactly how they are, and I'm gonna save them as SQL and injection um, um, commands, right? So, you know, let me just write that, and then I'm gonna put them. Since I know they work and the syntax is correct, I'm gonna save that, right? And then I'm gonna add to those. So the rest of these I use for something else, for the um, can you hack me website video that I'm going to make after this one. And I've already did it, but I'm going to show you how I did it. Well, I, anyways, so there you go. You got to mess with things, right? And I just took it from the book, so everything worked. This, like I said, this I had to change this where, and it gave me. If you look at the video, if you go back, it gave me hints saying you have syntax error in this area. So I just looked at this area and changed it to the one that was in the book, and that worked. All right. All right. Let's continue. As you can see, the injected query was successfully unioned with the result of the existing query, which allowed you to extract all the fields from the accounts table. I've opted to show only a portion of the data returned. Writing your own SQL injection tool. After you've gotten the hang of the mechanisms of SQL injection, try writing a Python program to automate the injection process. Our program will simulate submitting the website's login from form by emulating the HTTP request sent by the browser. Therefore, this project will require some basic knowledge of how the HTTP protocol works. Let's start by discussing HTTP. Understanding HTTP requests. Whenever a user interacts with a website, their browser transforms their actions into HTTP requests and sends it to the web server. An HTTP request contains the name of the source, the resource the user is requesting, and the data the user is sending to the server. The server responds with the HTTP response message containing the HTML or binary data that the user requested. These responses are then parsed and displayed to the user. To generate HTTP requests, you first need to understand their structure. For accuracy, let's use Wireshark to capture and inspect the exact HTTP request your browser generates when you submit the multiliday login from form with the username test and password ABCD. Return to chapter 3 for a refresher on monitoring traffic with Wireshark. Start Wireshark. Start monitoring the Ethernet Etho interface and then submit the login form to generate the request. Once submitted, use a filter to select packets containing the metasplittable server IP and then select the following stream options. Your request should look something like this. Alright, so it's gonna have us looking at stuff. Writing injection programs. Our Python program will send HTTP. And let's see if we've got this Python program. My hashcracker.py. Huh. Let's see, these are nice. SQL injection. I don't know, we might want to skip this understanding HTTP. I mean, you guys understand HTTP, you guys know how to use Wireshark, right? Done it before. I'm going to skip it. I don't think. Um, I mean, we know how it works. You got the get command, you have post commands, you're going to have three-way handshake, all that stuff, right? You know what your host is, you know what your sending, receiving. I mean, I think I'm gonna skip this section. I mean, I don't do that much, but I think I'm gonna because I think we've covered HTTP and how it works and Wireshark already, and this looks like it's just gonna have us do a refresher. So yeah, I'm gonna skip that part. Then we're just gonna go straight to writing the injection program. I'm sure everybody's happy about that. Usually I don't skip stuff, so all right, we're gonna skip that because I'm just gonna keep it fun. I'm gonna keep it funky. I'm gonna keep it funky. Keep it fun and fresh. Might have to pause the video on this one. Let's see how many minutes I've done already. All right, I got about 10 more minutes. Let's continue. Writing the injection program. Our Python program will send an HTTP request similar to the one we've just reviewed. Just you know how it works, except that it will contain our SQL injection payload as a query parameter. Create a new desktop folder called injections on your Kali Linux machine. Create a new file called sqlinjection.py. Alright, injections. Let's do that. So, move this over. I mean, that's the only, we only mess with this a little bit, huh? But see, look, you can mess with this all you want. And I'd recommend looking up SQL injections list, right? Commands. So I'm gonna leave this. I'm just gonna make it smaller. I'm gonna leave that running because I'm gonna come back and mess with that. That's fun stuff right there. I'm telling you. Um, go to hack the file, create a new folder. Oh, actually, let's let's do this first. Actually, no. Yeah, SQL injections. Okay, so we have SQL practice. Yeah, SQL injections. All right, so let's do instructions. Okay, and I'm gonna um, this I'm gonna call SQL. All right, and I'm gonna add. I'm gonna add these to it, right? And that works. Save that. Close. Here's some injections, and then here we're setting up the new. Okay, what did it say it wanted? It wanted to um, SQL inject. No, no, wait. Desktop called injections. So now we'll come here, create a folder, and we'll call this injections. Okay. And then we'll come in here and we'll create a pie called SQL injections dot py. That's a pie. And then we're gonna come over here to our the code they have online. I'm gonna copy that. I'm gonna paste this. And we could try to build it and stuff, but all right, that's a Pi program now. I didn't have to write it or nothing. It's ready to rock. Might have to come here and change some of this stuff, but we'll see if it runs like that. All right, let's go. Uh-huh. Right here. Oh, right here. All right. Let's see where we left off. In the folder, and then copy the following code into it. Boom. Boom. We define a function called get requests. Request equals get URL parameters. Containing the information we pass in a parameter. We replace the query parameter values with the SQL injection query. We must encode the query because we're injecting it directly into the URL. We can't contain space or certain special characters, which can't. The urlib library encodes SQL injection query before adding it to the URL. This encoding process will, for example, convert all spaces characters to 20%. When we've provided it with all the variables, the function will return HTTP requests, which will send through a TCP socket. Although not necessary, consider using the argparse library to parse the command line arguments. This will add a professional touch to your command line tool. Argparse library allows you to add custom flags in the help menu. Run the following command to test your new SQL injection tool. Oh, so I'm assuming this is going to be our host. And we're doing a multi-day. Jeez, that's a long ass command. The script prints the request and the server's HTML response. The preceding example shows a snippet of the HTML response, which contains the username and password pairs. Speak. A great way to debug your script is to capture requests and response in Wireshark. Um, Jeez, is that really the long? It can't be. That is a long command. It can't be the command. Oh, okay. So this would be changed to my host, multi-day, and page user. Oh my gosh. Alright, I've decided that we are not going to run that That's ridiculous. That command is so long and it is not practical. Even though it's cool to have your own script to do that. We're gonna read. It's just too. That's too complicated. We're gonna. I mean, that's not practical. You're not. You're never gonna use that. There's so much stuff you have to change here all the time in your command, which that that's ridiculous. But I guess it's there just to show us that we can make a script. I don't know. So we'll move on and go here. The script prints the request. Okay, wait, no. Using SQL map. We just built our own SQL injection tool, but existing tools can do much more than ours. One of the most see in this there's existing tools. One of the most popular SQL injection tools called SQL Map can automate the process of discovering and exploiting SQL injection vulnerabilities. Let's perform another injection attack on the Multiliday web app. Open a new terminal in Kali Linux and then run the following command to start the SQMap shell. It should be pre-installed. Alright, so this is an easier one. Let's do that. Like I said, it's good to have that script. Um, if I could copy and paste from this digital book, I would. I'm going to try to figure that out. I haven't done it yet. So for now, we're just going to skip that. Alright, so let's run SQL map. Alright, SQL map minus u HTTP. Is my nums lock working again? Yep, 192.168.1. Oh, Tiliday slash index dot php page equals user info p and okay, so it says use shell instead of. Alright, that looks like it worked. Let's come on, map. Alright, let me injections. Yeah, it looks a little bit better. And it just gives me a little idea where to look. The U option specifies the URL of the web pages we're targeting, right? Here we pass it to the multi-page login we attacked earlier. Within the shell, enter DBS. This will list all the databases on the system. Dash dash DBS. Says it doesn't appear to be injectable. Alright. SQL map first connects to the server and gets a fresh cookie. Then it uses the payload or not to test whether the query string parameter is vulnerable to SQL injection. Here are the comments out of the remainder of the SQL query. Lastly, SQL map injects a query that returns a list of databases on the server. You can see that there are 7 databases. Now we know this database server is hosting several databases. Let's focus on exploring the OWASP 10 database, which is the one we've been attacking. Run the following command to list all the database tables. The D flag lets you select a particular database. Tables lists all the tables. Let's see what it returned. I don't see any tables. This might be old commands. Hmm. I don't think that's the right thing. It says, yeah, it says it's, looks like that's the right. It says you shall. Guess you got to look at the help on that. It might be newer. All right, let's see what else we got here. Oh, DOS T accounts dump. This output shows the data contained in the accounts. All right, let's try that one. That would be the best one. Let's see if I can get me a shell. And anything I push does the same thing. No matter what I put in there, it does the same thing. And this is one that you're gonna have to come in here and do help. You know, yeah, this is doing the same thing for. Unless it did something wrong on the address. No, I don't know. Huh. I'm gonna have to come back and mess with that. But I mean, I guess this does that. It's automated. That's fine. You have to mess with that more. The output shows the data contained in the accounts table. All right, we already. That's cool. All right, hashing passwords. Let's see how long this chapter is. I have to cut it in half. Yeah. All right, yeah, this is long enough. We're gonna cut this in half. We're gonna call it a day. I hope you learned something, and I'll see you on the next Hack the File. Enjoy.